So we are going to write factoring the sum and difference of cubes. Nope, you can just do your regular pencil, pen, whatever you're using is fine. My colors are not very pretty because I could only find gray and brown. So those are my colors today. All right. So these problems, when we see them, you're going to see problems that look like something cubed plus something cubed. That's the sum of cubes. Or it could be something cubed minus something cubed. So they could look either way. And the formula for this is going to look real complicated, but we're going to use the colors to make it not complicated, okay? So here's the formula. For the plus version, it is A plus B, and then it's A squared minus AB plus B squared. Almost right. So that looked kind of complicated. Wait for it. Yeah. All right, then the minus version is going to be A minus B, A squared plus AB plus B squared. So there are two ways to remember this. And I am never going to memorize this formula. I'm never going to go back and look at my paper and go like, which one's A, which one's B. I'm never going to do that because I'm going to remember an acronym and I'm going to remember the colors, okay? So here's what I do. I remember the acronym SOAP. This is how I remember my signs. The first one is the same sign as the original problem. See that? If this is a minus, this is a minus. If this is a plus, this is a plus. Everyone see that? Same sign? Same sign. This one is the opposite sign. Same sign, opposite sign, opposite sign. Everyone see that? Okay. And then at the end, it's always positive. SOAP. Same sign, opposite sign, always positive. Everyone see that? Okay. Now, here are the colors. Take one of your colors. It is half and half, okay? I think of this as like the short parenthesis. This is the long parenthesis, okay? And the short parenthesis, you do the thing once, and the long parenthesis, you do it twice. Each color gets half, okay? So the way that I think of this is A gets written once, A gets written twice. See that? A times A. A times A. And then here's an A times something. So we get the letter once, we get the letter twice. There's going to be 2 here, but I've already done half of the parentheses. See that? Because there's 1, 2, 3, 4, 5, 6. And I've done 1, 2, 3. Okay? All right, now I'm going to finish them. I'm going to pick my other color. And I've got 1, so I finished the first parenthesis. And then there's finishing that one, and then this times this. So I'm not going to memorize the formula because I'm just going to follow a pattern. All right? It is the most confusing it's going to be right now. Once we do a couple examples, you'll be like, oh, I kind of see how that works. Okay? So what we're going to write next before we do the examples is we're going to write some perfect cube numbers, and then we're going to try some with some numbers in them. Okay? So the first perfect cube number is 1 to the third, and 1 to the third is 1. Okay? The next is 2 to the third, which is 8. Okay. The next is 3 to the third, which is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third, 216. 7 to the third, 'You guys have calculators in front of you. Oh, that felt like cheating. 343. And then we're going to do one more. We're going to do 8 to the third. 512. Okay, so from my experience, unless the number has a GCF, it's all bets are off if they have a GCF. But unless they have a GCF, you only see up to about 7. I don't see much higher than 7. Now, if they have a GCF, the numbers are bigger than that. But if they don't have a GCF, then they go up to about 7. Okay, so here is our first example problem. Okay. We're going to do 27m to the third minus 125. So the very first thing we're going to do in these problems is we're going to rewrite it so that it looks like something to the third minus something to the third. That's the very first thing we're going to do. So I'm going to write it as something in parentheses cubed minus something in parentheses cubed. So 27 is what to the third? 3. Okay. So this is 3m to the third. And then 125. 125 is what to the third? 5. Okay, because I said the answer. Okay. So this is 3m to the third minus 5 to the third. So that means that the 3m is the A, and the 5 is the B. Okay, so now we're going to follow our pattern. So we have one little parenthesis and one big parenthesis. Our signs are going to be the same sign, the opposite sign, and always positive. Same sign, opposite sign, always positive. And now we're going to do the colors. So for A, I'm going to take what A is and I'm going to write it down once. So the first parenthesis, you just write it once. And then the second parenthesis, we write 2 things, we write 2 things, we write 2 things. Okay? So I'm going to say 3m times 3m. And this is 3m times the other half. Okay, see how I did the first half in one color? Now I'm switching colors. My B is 5, so now I'm going to finish with that. So I'm going to do 5, 5, 5 times 5. So I didn't really use the formula, I used patterns. It's easier to remember. Does that make sense? Okay, so now all I have to do is actually multiply stuff and make it look more mathematical and less like, oh, I did an art project. So the answer would be 3m minus 5, and then 3m multiplied by 3m is 9m squared, and then 3m times 5, $15m, and then 5 times 5, 25. And if you could factor this quadratic, you would. It almost always doesn't factor. Like if you said, Miss Rice, can you give us an example of one that does factor? I would say, no, I can't. That is how seldom it factors. Okay? All right. That's our answer. Okay, let's try another one. All right, this one, 81 x to the third minus 4. 81 x to the third, ooh, minus 24. There was a 2 in there. Minus 24. Okay. Now, if I look at this one, I go, okay, it's got the format of difference of something. It's got an x to the third, which makes me think of cubes, but the numbers are wrong. 81 and 24 are not perfect cubes. So when I see this, when I see an x to the third, but my numbers are wrong, that makes me think, oh, it's probably got a GCF. Okay? So what number do we think the GCF could be? Instead of thinking what's in common between 81 and 24, instead of that, look back at your perfect cubes and think, what could I divide out of one of these to make it become one of these? So does 1, 8, or 27 go into one of those? Does 8 come out of both of these? No. 3 goes into both of those, and it would leave an 8 behind. 8 is the perfect cube sitting there on the end. Okay, so if we took 81 and we divided it by 3, would it still be a perfect cube? 81 divided by 3 is 27. Yeah, that's a good sign. That's what we want. Okay, so take the 3 out. 81, nope, not an 81 anymore. 27 x to the third minus 8. Okay. So what I'm going to do is I'm going to rewrite this so that it's written as something to the third minus something to the third. So I have the GCF of 3 in the front, and then I've got something to the third minus something to the third. So what would the first one be? 3, so this would be 3x to the third. What would the second one be? 2. Okay, so just like last time, I'm going to have a set of small parentheses and a set of big parentheses, but this time I have a GCF of 3 in front of my final answer. This is a subtraction sign, and so what should my signs be? Okay. So same, opposite, always positive. Okay. I'm going to take my first color, and what should I write? Three x. Okay, what do I write here? 3x times 3x. And then here I just write a 3x times, and I leave a space. And then I'm going to switch colors and do the other half. So I'm going to do 2. This is times 2. And this is a 2 times 2. Okay, so I've got my GCF of 3 in the front. What's my first parenthesis? 3x minus 2. And then my next parenthesis, I've got 3x times 3x, which is... Okay, and then I have... Okay, and then I have... Okay. Okay, next one. 2 plus 250 m to the third. What do you guys think? We could take out a GCF of 2. Do you guys like the order that it's written? I don't love it. It looks weird. So what should I write? Okay, and then we're still taking the 2 out. So 2, and then what would that leave us? 125 m to the third plus 1. Okay, so something to the third plus something to the third. And what do we have? Okay, 5m to the third plus 1 to the third. Okay, so we're going to have a GCF of 2, a little set of parentheses, and then a big set of parentheses. I'm going to go ahead and let you guys fill in these parentheses. So remember your acronym SOAP. We got same, opposite, always positive. Remember your 2 colors. What was that? Oh, that's fun. That's fun. Was it a bunch of binders? Oh. No, that's fine. I'll get them. Okay. No. You saved my life. Okay, maybe that was drastic. All right, how did we do? Good? Okay. So I have a little assignment to practice this. You have your choice, okay? It's double-sided. You do one side, not both sides, one side. One side. How many sides do you do? One side. Okay. You can do both if you want, though. If you do the other side, if you do both sides, you get extra credit. Okay. So one side has a punchline. The other side has a puzzle where you like do it and then you cut out the little pictures and you glue them on and you make a little picture of an animal. So that's fun. Look how fun that is. Okay, so one side has only sum and difference of cubes, and then I think the other side has some difference of squares on it too. Yeah. Okay, so there's that, and then there's and then we have a video on solving by factoring, which is review, but is good review because a lot of us have forgotten about the quadratic formula and how to solve by factoring. So